So the conditional statements, decision making. When we want to discern some issues, objects, then we have a rule, right? Rule to decide, rule to determine. So how we can describe the rules. So that is simply the if, then, if else type of statements. Okay. So simple condition is in mathematics, in logics, it starts from predicates. Predicates is a statements that turns out to be either true or false. So if it is true, then it goes to next to statements. If it is false, then goes to another statements, whichever designated. Okay. So in language, it looks like if condition and action. For this condition, if this condition is true, then take the action 1. Otherwise, action 2. The language here is if and else. In order to make this in block, then if condition ending with the colon is a must symbol. If you do not have this colon, then there will be an error, or your logic is not implemented properly as you desired. Therefore, it runs differently from what you originally planned to do. So if action 1, else action 2. We can expand this further, not only for one condition, but we could have multiple conditions. So if first condition is true, then action, first action. And after that, if this is not, for the rest of the case, we'll ask another condition. So for the condition 2, if that is true, then that small portion for the rest cases will be for the action 2. And then there is a else or else if. Else if can further as many times as you can. But at the end, you could do else. Therefore, everything of this considered, okay? Everything. So other than all those situations already considered, the rest will be considered here. So else, action 3. Okay. In mathematics, condition is like this. If age is greater than or equal to 21 or less than or equal to 36, perfectly fine. In typical language, we need to split this, because if you see here, this is an operand, this is operand, this is an operator. Usually operator, there may be a binary operator, which means based on binary operator, there is an operand on left, operand on right. That is binary operator. That operator is applied to 2 operands. That's a binary operator. There's a unary operator available, like negation, right? If we say not, if this is not the case, not negative negation of some condition, then we have, there is only one operand and one operator. So we call that operator unary operator. Okay, so this is funny in mathematics. We have 2 operators in one statement, right? And 3 operands. So we cannot point to what is this operator? Is this a unary operator or binary operator, right? So this is a mathematical inconsistencies. We call that, yeah. Computer scientists say, hey, the dummy mathematicians. So this is like that. So we make this, okay? So operator, if it is a binary operator, usually comparison is a binary operator, right? So 2 operands. So binary operator, 2 operands. But these 2 conditions can be combined. So we have a connector, logical connector. Logical connector means that is a connector that combine 2 predicates logically. Whether this is true or false, we combine. But in Python starts from not start from the state which is not well formed. Not like Python, not like C. Python was the product of one, I believe, one intern students. So during Christmas break, he was so bored and, hey, I want to make a one language. And then he created the Python. Yeah, something like that. But anyway, usually the language is created, invented by students. Not like Java. Java is the language invented by professional computer scientists when they were working at Sun Microsystems. I explain the Sun Microsystems often, right? Yeah, one of the reasons is Sun Microsystems was a really, really good company is because two of the employees who once worked at Sun Microsystems, now the co-founder of NVIDIA. You know, NVIDIA is really now so one of the major tech companies, right? They manufactured GPU. I think many of you are playing computer game, then GPU is a must. So with those two guys from Sun Microsystems and one guy from, I think it's Huang, not Jason. It's very similar to Jason, right? But anyway, from Taiwanese. He studied only I think 1 year at Stanford. But his bachelor, he studied it at Oregon University, University of Oregon or Oregon State Universities. He studied there and then he studied at Stanford. And he was lucky to meet one professor at Stanford. He's also from Taiwan. He's the founder of TSMC. TSMC stands for Taiwanese Semiconductor TS Manufacturing Company. TSMC is very, 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 I think there's emerging companies doing semiconductor, like Samsung, but Samsung is doing their own, the factories invented big money to make that. So there's a multi producing companies. On the other hand, the TSMC is more, they have factories. So if there is an order, then they make it, small products, which is current technologies, right? The current technology is not open architecture, but they build computer architecture for their own purpose. For example, smartphone, it is nothing but computer, but smartphone computer is not like your laptop computer. Tesla has lots of computers in it. It's not like your laptop computer. It is a computer, but it is a very specific designated, strict purpose computer. Many such cases. But anyway, what did I want to say? Okay, so language. So this Python was invented by A students. If you are interested in, then maybe a year later, next spring, I am teaching also another language called the Swift, which is the next generation of Objective-C. That is the language that we need to use to build iPhone applications, right? I offer that course once a year. If anyone wants to stay till next spring, then you may take it. Swift is a language, that is the language invented by the students. When he was a PhD student at University of Illinois, Urbana-Champaign. Anyway, so there's a language. So as you see here, this is an operator. We have a variable and value pairs. For the operator, we may have two variables. If there is a variable, then variable needs to be evaluated. Therefore, we need to have a value. For example, age is greater than or equal to 21, then we know the value of 21. We do not know the value age. Therefore, we need to make sure what value is held in this variable. That is called the evaluation. So evaluate this variable. So whatever value in it will be compared with the 21. And this entire condition, so-called predicate, will return either true or false. Same thing if we have two variables, height less than or equal to depth, then height is above the ground, depth is under the ground. I'm not sure that's good description, but anyway, height and depth, compare those two. We cannot compare height and depth, right? We can, but compare the outcome of the evaluation of this height, the outcome of the evaluation of this variable depth. Then we know the value. So compare two values. And one variable, it could be a condition as well, right? For example, red light. Is that red light or green light? It turns out to be yes or no, right? True or false. So by itself, that is a predicate. It gives us whether it is true or false. So condition gives us true or false. So this is an example of those. We can get the variable from user. We can assign the value to a variable. Therefore, the evaluation of this variable will be simply 3. Or the computation, whatever the computation on the right side and assigned to the left side, which is a variable. So evaluation of this grade is the computation result of this. Or if it is a list, then we can simply see, hey, what is the 4th element in the list called the grade? Then we can get, right? If it is a dictionary, then we can say, what is the give the key, we can get the value. This is the dictionary.get and the key. Or you can simply grade square bracket and the key in it. Simpler, right? Grade square bracket, any. Then you can give us the value to this key. Okay. So we can get this, right? From the user. We can get age in integer, which is data. In the next statements, conditional statements, there is a condition. So to operand, in other words, that is an argument, an operator. So data is greater than or equal to 21. So data should be evaluated. But by the way, data already bind to a value given by user, whatever the age is. 17. 17 is greater than 21? No. So this is not. So it goes to else. If it is true, then it goes to this. 24. 24 is greater than 21. So it says you are already an adult. 17, which is not greater than 21. So this condition gives us a false. So it goes to next. You are still a child. So you can say, oh, you're eligible for drink, or you are not eligible for liquor purchase, things like that. Or you're eligible for driving. Input. Okay. There isn't any error. If I say, is there any error, then this statement itself is not really the error. When it comes to here, data is greater than or equal to 21, then it gives you an error because this guy wants to compare with the value. So data needs to be an integer. But as this data is not an integer, because input is the characters given from your keyboard. Keyboard does not distinguish from letter keyboard or a number keyboard or any symbol keyboard. Everything from the keyboard is a character. It's not a number. Although it looks like number there, number key, but it's not a number. So you have to convert that to a number, right? Connecting. So there is a connecting. Python, you can simply say and, A and D. Instead of this 2 vertical bar, you can say or. That is Python. Okay. So again, if you say, if given this list, if A sub 1 greater than A sub 3, which is the second element, and this is 4th element. Second element is 21, 4th element is 3. Is it 21 greater than 3? Yes, it is, right? So insert 4th elements into the second element here. So number 3 will be inserted one more, right? So what is the output? If it's to print, then it'll be 1, 3, 21, 5, 3. Can we remove the last element 3? There is a function called the pop. So a dot pop, open and close parenthesis, no parameter. Then it'll pop the last ones from a list. That's what this guy says, right? Pop. Remove. If you say remove, then remove is different from pop. Remove. This guy will remove this value itself, 21. Read the manual. So 21 means not the 22nd element, but the value 21. Remove value 21. If there are multiple the same values, 21, then the first one will be removed. Dictionaries, similarly, we practice this, right? And operator in print statements. So we can also make some conditions. Given this dictionary, my conditional statements here, pay of John. John is the key, right? If there is any keys there. If there is no John, then what would it happens? If there is no John in this dictionary keys, then it'll give you an error. To avoid that, in the case that if you do not know all content of the dictionary, because the dictionary keep changing, updating, then you have to, that type of things is exception, right? Because the exceptions needs to be handled properly. In programming language, it is called exception handlings. So exception handling is also very, very important, particularly in secure coding, cybersecurity. But we do not do that here. This is really basic coding. Assume John is available in this dictionary. Then pay of John, then we know what is it, 75. Is it 75 less than 80? Yes, it is. Then we update John's number to increase by 5%. Oh, this is pay. Connecting. Oh, yeah, we already looked at that, right? Two conditions are connected by AND, logical connector. AND is a logical connector. This is condition. We have two conditions. Two conditions are connected. If state is in New York, age is 21, then by the state law of New York, this guy will be an adult, which means allowed, permitted to drink alcohol. Driving age is, I think, 18. And learner's permit, maybe 16 years old. My kids are all grown up, so I don't remember that. But they took that, right? At the age of 16, they got a learner's permit, and at 18th, then driver's license. That is a license, right? Permit is not the same as a license. A little bit similar, but not exactly. But drinkable age is different, right? It's 21 in New York, depending upon the states. Some other states, I think 18, right? New York is more restricted. As I said, it'll continue, not only if and else, but if, else, as many times as you can. And finally, else. If we do not have a finally else, what happens? Only have if, elif, and do some other statements. Will there be an error? Or some other issue? There's no errors. So grammatically, it is valid. But semantically, you lose some conditions, right? By describing this condition, you need to cover entire spectrum of the cases. But if you stop somewhere, if, elif, then the rest will not be considered, which will be eventually lose a point where cyber attackers can intrude because you didn't protect entire spectrums, right? Like we need to protect the entire border, southern border, then should be protected entire. If there's any loose points, then there is a point of intrusion. Okay, this is a conditional statements, and we will move to iterative directly. Any question, by the way, about conditional statements or branching statements? Branching, why we call branching statements? So some states may be split based on that branching statements, okay, like a conditional statements. Given a data set, decision making is to to divide the given data sets into smaller and smaller and smaller. And therefore, finally, we can say, hey, this group substance will be the honor roll. Okay, so that you guys may be called by dean's office and get celebrations, decision makings. Looping, iterative conditions. Why repetitive operations are needed? Example, the same grading rule needs to be applied to each of all the class students. So same action, same rules needs to be applied to as many times as the data is available. Then there's repetition, right? That is really, really helpful in coding, unless otherwise you have to code repetitively one statements per data, and it is worse if you have a million data available. So iterative, you can specify a number of times. Hey, I want to repeat this 10 times, 5 times. Or other case, this is an open, I would say. Yeah, the other case is we want to work on for the case, which is a closed world. Data type list, then that is a closed world. Closed world means it is not open world. It is a limited number of elements in it. So that is closed world. So we can do some repetitions. Depending on given data type, then we can say for each element in a data type, it could be a list, it could be a tuple, it could be a dictionary. So for each element in a list, I want to do some action. How many times it will take that action? As many times as the size of that elements. If there are 5 elements, then 5 times. If there are 1,000,001 elements, then how many times? Million and one times of iterations. Or files. File is also a closed world. It could be Python file, it could be doc file, or it could be JPEG files. So file is limited, right? So I want to read file. If that is a plain text file, then I can say, I want to read line by line. I want to read entire in that file. That type of things. So for each line in a file, you can specify that, right? Website also. So anything that you want to load on your computer, then you can read. The way that you can read some action iteratively. That way you can see, you don't have to specify, I want to read one line for how many times? Or you can simply say, I want to read each line, whatever available in the given file. Then you do not have to worry about the size of the files, right? If you know, then you can say that, but usually not. For cybersecurity professionals, for example, if you want to search some investigations on digital media, then you need to do repetitions, right? Unless you do manually. So looping is like this. Start from the big world, you can go smaller and smaller and smaller. Okay. Or you can start from the smaller world and bigger and bigger and bigger. Each case, the only difference is that any conditions is in the direction of growing or direction of shrinking. In either case, what you need is, you need to have a terminal conditions, right? Given size, I want to consider all the elements in that given data type. Then if there is 0 data type available, then that loop will end at the time, right? That is a terminal conditions. If it grows, then a little different, right? If growing, then you have to specify, hey, I want to collect some data from the web page. if you don't say when to stop, then it keep running. So you want to say, hey, I want to collect 10 or 100. Then that is the condition that can terminate the loop. So statements will be like this for a number of times, for each in a list, for each element in a file, or you can say while some condition is met. So we have a while loop or for loops, two types of loopings, while or for loop, depending upon the case. Or some cases you may use one or the other. Some cases one may be better than the other. Some cases, if you want to let it run continually, then while loop is better, right? While true, condition is true. You can say while true, then always true to some actions. Then whatever the block inside the while loop will be running continually. This is a case for surveillance, the systems, any monitorings, any sensoring of your systems, then you better let it go, right? Continually. Example of for a number of times, then you can say for each in the range. You need to say range in this case. I want to count. I want to do this 5 times, then 1 to 5. You need to say range. This each is a variable. For each in this range. So this variable holds at first number 1, and second value bound to this each is number 2, and number 3, number 4, number 5. So if we say print each, then it'll print 1, 2, 3, 4, 5. Or for each in a list. So given a list, we can say for each in list lst, and then we can print each. Same thing here. This is a list. Each means this is a variable that can hold element from the list. So first element held by this variable is number 1. So number 1 is used to print. So you can make multiple actions within this for loop. When it is done, then come back here. Next element in the list. That next element, which is number 3. Number 3 is held in by the very same variable each. So second time, when it comes to in the second step, second cycle in this looping, the value in the variable each will be the second value. And the third cycle, there'll be the third value. And go and go on. In a file, then you can say for you need to define the file. So you need to first open file. Open is a function. This isn't a built-in function. In this parenthesis, you need to say a explicitly specified the path expression to that specific file. So this language should point to the file explicitly. Your language is not intelligent. There's no such language available. You need to say explicitly, therefore there is no ambiguity. Okay, so open a file name with a complete expression, then it can understand what file that I need to open. So as a file is open, then this is a variable f. That variable f points to the beginning points of that file. Beginning points of that file. So that file, in that file, each means entire. If we say for read line or simply something else, then it could do something else. But in general, print it. We'll have a more specific, more detailed description of file reading. While loop. While true, within the while loop block inside of this. So you have 2 statements, right? First, print whatever x is. Still true, right? And if x is greater than 100, if it's not greater than 100, then if this is not satisfied and there is no nothing, then go back here, next cycle, and print next x, print next x, print next x, print next x. But when the x is over 100, then break. So this while loop will stop. Or you can say, rather than say break, you can do, if this is variable, so you initialize anything, say continue equals true, variable continue equals true, then continue is nothing but true. So you can say while continue, so it continues. When it comes to some condition, if you change the value to this condition, continue, here you can say continue equals false. At that time, when we come back here while loop, now continue, variable continue holds the value false, therefore that is not anymore true. So this while loop is done, and go to next line of statements. So we'll practice that. So we have a condition, these conditional statements that we looked at in the previous module, and then we have a loop, right? This is looping. So in this condition, we need to say whether it is continue to do or false to stop. That is the loop. So 10 iterations, add 1 to 10. Then what you need to do is, if you want to do while loop, then true. Therefore, there may be break somewhere here. Initial value is 1, total is 0. So we want to add 1 to 10. If the value is less than or equal to 10, then we continue to this. So at first, the value holds number 1. So number 1 is less than or equal to 10. Therefore, we update the total. Total, this is a variable, equal, right-hand side. So we have to compute the right-hand side first. In the right-hand side, total, what is the total? Currently, total is 0, right? 0 plus value. Value is 1. 0 plus 1 is 1. So 1 is assigned to left-hand side, total. So total is updated to 1. Initially 0. But after this statements, total is 1. And then another statements, value equals a value plus 1. So right-hand side should be evaluated first. So currently, what is the value? Currently, value is 1. So 1 plus 1 equals 2. So 2 is assigned to value. So value will be 2 here. Total will be 1 here. So that is the if statements. Else is not considered because if statements is considered. So go to next cycle of a while loop. Still true. So there's an if statements. Value is less than or equal to 10. So value is now not this value, but the value that was obtained from the previous cycle, which is 2. So value 2 is less than or equal to 10. So go to that block, if block. So now value is 2, total is 1. That computation result is assigned to total. Now that is number, I think, 3. And value is here 2. 2 plus 1 is 3. So new value is 3. And come back here for another. And it goes until value becomes 11. So when value becomes 11, then 11 is not less than, not equal to. Therefore, skip this, but go to next statements, which is else. And here, there's the end of that value. We print that, and then finally break. So no more go back to this while loop. That is while loop. If we do this, some of the improvement here, I wanted to what is this? In this case, here while loop is true, right? Always true here. Instead, to make the case of terminations, we make here break statements. Another way that you could do is while value is less than or equal to 10. there's a condition with the while statements. As far as value is less than or equal to 10, we do this. We continue to this. There's improvement of this, right? So one while loop can do while, if else statements. This is a previous ones. This is an improvement. Same thing can be improved like this. So initially value is 1, total is 0, value is less than or equal to 10, of course, then go into that while loop block, and total is updated and value is increased. Keep going until value is 10 and 11. When it comes to 11, then it is not. And go to this print statements. These two statements, codings, returns exact same output, but which one's better? If you are a professional developer, then I think this purple code may be better. But depends on the size of this, right? If you do further more longer, but in this, if we compare these two as they are, then this purple code better than the white code. Still, we can improve. In this case, the improvement is rather than say total equals total plus value, there's another operator, total plus equal sign value. Plus equal sign is this plus and equal sign combined. So we don't need to repeat this total. Total equals total plus value means total plus equal value. Same thing here. Value equals value plus 1. That is nothing but value plus equal. This is an operator. 1. Another improvement for this, we can make a for loop. Rather than while loop, we can make for loop. For I in range 1, comma 11. So we don't need to worry about values. We worry about total only. As far as we know, how many times are the repetitions, right? Given the value starts from 1, less than or equal to 10. So it repeats 10 times. If you want to make 10 times, then you can make range 1, comma 11. So 11 is not up to 11, but the second value is exclusive, not inclusive. So it counts from 1 to 10. If you compare these two codes, then you can simply say, hey, this is better, right? Why? Number line in the code shorter and bigger? Is it the reason? That is the reason in naive way. If you are a knowledgeable coder, then the value here, this value is consuming the memory, right? In the memory, there is some location, that memory, whatever the size of that memory that is consumed, that is held by this variable value, which is unnecessary in this purple code. But anyway, in this case, that is needed. That has been used. That's waste memory. So memory needs to be accessed multiple times. If this is 1,000,000 times of while loop, then 1,000,000 times of data access. Not only the memory space issue, but also computation time. This may be shorter time, right? So you can do iterations. You can make add 1 to 10, then you can make a answer only. Add 1 to 10, you need to describe all the equations. 1 plus 2 plus 3 equal 55. Or you can display more for each step. Initially 1 equals 1. 1 plus 2 equals 3. How you could have 55 finally. You can display that way, right? Can you code this 1 to 10? That's This guy gives you this, right? Can you make it a little further? What can you display all each steps in great detail? You can make a for loop in a data type. So for each in a list, LST, for each in a list, so MERCY, that is a string. Okay. So what is a string? String is a string of characters, right? String is the concatenations of strings, concatenations of characters. So in Python, if you have a string, the string can even split further. So it is not entire mercy, but it could be M, E, R, C, Y. So if you do this, then it gives us in a list M, E, R, C, Y. LST2, there's a number of those. You can make a sum. If you have this LST3 for each print, then in the first line, you have M, E, R, C, Y. The second line, cipher. Third line, 1. Similarly, if you have this, then the first line, M, second line, E, third line, R, so on and so forth. So we have also dictionary, reading files, open and file name. As I said, this file name should be fully expressed path, right? Path expression is needed. Mode. If we want to simply read it, then you need to say R. If we want to write it, then W. This writing is one-time writing. If we want to write it, write to the same file. If we want to write the second time, then second time of writing will replace the first time of writing. Okay. If we want to attach it, append, then you need to say A. A is append. If we want to read something in binary data, then B. So read, if you want to read the binary, then RB. If you want to write binary, then WB. What it means is that in cybersecurity, if you want to investigate on image, then you need to read the image in binary code, see if there is any unwanted text embedded. Then you need to read it in binary, like this. That is so-called steganography, but there is another, right? So we can read the files. Let's say this is a file, temp file.data, DAT, read the file. You can open that file, print. Or if you want to print line by line, then for line in G is open this, and line by line. So outcome of these statements, if we say print G, then it gives us this. This is an object wrapper data in response to print G, which is not readable. So you need to read the file line by line. So if you say open and print, then it gives us this ugly code. If you want to write line by line, so first line is 57F, Dobbs Ferry, 43C, London. Then first line of the file displayed first line and second line in the second display. In order to do that, you have to do this for loops. So for line in G, so print that line. If there is any error when you say this, then usually that is the case. This file is not known, unknown file. If you want to let it know explicitly, then you need to specify. If you are running on C, if you're running on Windows, then you need to specify in this way. From the C drive, C:\\. So full path expression to file name. If you're running on Mac, then usually on the users /user/ your name / whatever the directory to the file. Okay. Okay. So that is needed when you say open file, should be either this or that. So this file needs to be explicitly pointed by path expression here. So specify fully expressed files. So it could be, you can say open file and file.read. This read is a function associated with the open file. Or read lines or split lines. You need to practice, otherwise you cannot see it. So back to our lab 3 on your colab. I'll give you 1 minute. So bring your colab. All right. This lab will do lab 3 and lab 4, which is part 3 and part 4. Part 3, conditional statements. So this is a predicate. 5 greater than 3, yes. Right? So if you want to practice it, then you can make here, and you can say 5 greater than 3, and execute it. It gives you true, right? But if you change this to less than, it gives us false. Okay. So consider list. You can compare it with, say, if they are the same. Double equal sign means equality checking. Single equal sign is an assignment from right side to left side. Double equal sign means equality. So they are the same. LST of 1, second element, which is 8, here, are they same? False, right? So we can execute this entire files, then this one already done, this one somewhere done, and this false gives us the last one. This is a false. So if we want to do this, make sure whether that is true or false, then you can do it here. This is a false, of course, right? Second element in this list, 8, is 8, which is not the same as number 4. Therefore, it gives us a false. So that is this. The last one here. LST index 2, which is third one, 23. Is this greater than maximum LST? Okay, this is an operator. Left-hand side and right-hand side. So left-hand side, we need to get the value, which is 28, 23. Right-hand side, max LST. This should be evaluated. So what is max LST? Max LST. So we need to see what it is. Max LST is 23. So right-hand side is 23. Left-hand side is 23. If we say greater than, then what is the answer? False. Right? They are exactly the same, but this operator asks, the first one is bigger than the second one. No, they are not. The first one is not bigger than the second one. This is a predicates. Conditions, we can do if, else if, finally else. Make sure that in general case, there is no lose point. Okay? If there is a lose point, what happens? As I said, that is maybe error point, or there may be intrusion point of cyber attack. Let's consider this. Print, welcome to the store. And we enter your age in integer, so that is input. And then we say also integer. We convert that to integer. So age is integer. If age is less than 18, you are not eligible for alcohol. If age is 79, too old. We need to be careful, right? Too knowledgeable, age. You can say alcohol is not good for your health. Other than that, total price, whatever, right? So if we execute it, then it says, what is your age? Then 15 years old. Then it says, oh, you are not eligible for alcohol, right? What is your age? My age is 101 years old. Then, of course, alcohol is not good for 101 years old person. Not all, right? Not 100%. Maybe some of that age may still enjoy alcohol. How about the combination of the conditions? Yeah, we make conditions all the time. Rather than this, if we say L, if, for example, greater than or equal to 18, the age is less than or equal to 65, then this price, and else we can say we have a senior discount, right? So age is 56, then total price is 1999. Age is 68. Then you're lucky you have a senior discounts. So as you can see here, this is a combination of the conditions, right? We can say this, or as I said, age is greater than, age is greater than or greater or equal to 18, and age is less than or equal to 65. Then it works as well. For example, 45. Then cash or credit card. If you have 69, then you are senior. So either you can express in the combinations of conditions, you can do this or this using the connector AND. Okay, a little bit of the things that we have here, blanks, right? This type of questions will be asked on your midterm exam, right? Blanks. According to a condition, code may take one or more actions. Okay. Let's see what I am trying to do. It says, depending on the size of a list, more element is appended or one last element is removed. How many elements we have here? Let's say 1, 2, 3, 4, 6 elements in LST list, right? So I want to append the first one more. I want to increase the size of this list. So it's not first type of questions, just practice. If the length of a list is greater than let's say less than or equal to 5. If it is less than or equal to 5, is the small size of a list, then I want to increase it. Other than that, I want to pop the last ones. Okay, so what happens? If it is less than 5, then I want to increase it. But we have 6, so last one is popped out. So number 10 popped out, right? If I want to change this to, for example, 6, okay, then what happens? This is exact 6, the size of this list. Therefore, the very first one will be attached to the last. This is not moved to the last, but the very same value will be attached to the last. One more. So if we run this, then this is a given. The first one is attached to the last. Right? Those are conditional statements. Write a Python code to check. Let's say if I give index 2, which is 0, 1 to 11, right? Then it can compare with the next ones. Given this index, one more index, which is 5. Check if they are ascending, which means 11 is less than the next ones. If it is not, swap. So it'll be 5 and 11. How can we make it? If you want to swap, then hint, temporary variable is needed. Let's say 11 and 5. 11 and 5, you have this. Then you have to swap this. How can you swap? Then you have to say, this one, the smaller one, the one that you want to replace. You want to make this a copy somewhere. The same value. This is a smaller, this is the left side, right? Your case, maybe this is left side also. Yeah, so I want to resolve this somewhere. So I replace this with that. Then this, so replace it with the next ones, right? Because I already resolved this once to the temporary variable. The later, after this, you can bring that temporary variable into that ones. Okay, so 3 things needed. 2 values needs to be swapped, then 1 more temporary variables. Hold something that can be replaced first so that you do not lose this. Okay, think about that carefully. Many cases you do, right? If you want to swap, then hey, I want to copy this to somewhere, and this guy override it, and then the resolved ones comes back. Question? No questions, right? Iterative statements. So loop. Adding every other number in the range. So range is very good statements. So if you want to practice the range, then you can do here. Range 1 to 10. See what it is. It is simply like that. But if you want to do for I in range, print I and execute it. Then from 1 to 10, 10 is exclusive. So 1 to 9. Because this is a print, it prints like this, right? If we want to print this in one line, then you need to do and equals this. Then it'll be 1 line. Because they are all connected. If we want to make one space, then make space. So it'll be space like that. If we want to put their plus sign, then it'll be like the plus sign, right? So what you need to do? You need to do here for I in yi, because I used I here, right? So it should be I in range 5 to 20 by 2. Oh, double in 96. If I want to see that in what is it, 5 to 20 by 2, we need to make here print. So 1 line, I want to change it. So this is next ones. 5, 7. I want to make this. So 5, 7, 9. So if you want to add this all, then it'll be 96. Initially sum equals to 0. I want to add into this 0 initially, whatever the number that comes from this range. So initially 5, next one 7, next one 9, we add each of these numbers into sum. Finally, I make sum. This is the question that we looked at, right? And that's available in the slide. This is the same as this, same as that. How can you make this? then we need to have here, we need to put I, right? Print I, and then we need to say plus for each. So it'll be like this. Still, it's not, right? So up to this is okay. 96, that is okay. I want to remove this, the last plus sign to equal sign. So it'll be like this. So lots of the conditions, branching statements is needed. So this is homework assignments. How can you make this? The hint here is I didn't give you a hint here. So you need to make sure that is the end, right? You can do many things, but for example, if we know this 20, is 20 included? 20 is not included, right? So if it is 19, we print this followed by plus, right? Initially 5 followed by plus. That is this statements, print statements. So what you need to do is, if it is 19, up to this, you let it go like this. If that is 19, then rather than this, you need to put plus sign at the end, right? So not only this one statements, you need to have branching statements. Follow with the condition. Another one is for a list, we can count the length of that list. So sum equals to 0. We make that. What is the average? What is the sum of what is average? So we need to make, in order to make an average, then we need to make a sum, total number, and how many quantity is needed, right? So we make quantity, and we need to make sum from this list. So number should be added to sum. So in this, for each, rather than each, you need to say for num in list. Then it'll be like this, right? Total number is 61. If you add this all, then that is a 61. How many? 1, 2, 3, 4, yeah, 6. 61 divided by 6, then it'll be 10.1666. But if you do this in this placeholder, the decimal place 2, then it'll be this. This is very handy, right? Above whatever this, all remembered. So one time you print this without having to rewrite everything. You simply do print that, execute it, so that you can compare this with that. What does it make? It is made by this. So there is a homework assignment 2 and 3 and 4. Okay, finally, reading files. Okay, if F is already open file, F is a file already opened, then you can do read, function read, or function read line, or read lines. I explained that here. Read takes F and read it to n bytes. Similarly, write function writes given the buffer to the I/O systems. I/O system, one of the output system is standard out is a monitor, or standard input is terminal. Read line means it reads and return a line from that open the file. Read lines, all the lines in a list lines. Oops. So this is file expression. File expression is, we play with the readme. So if you open this, there's a files, sample files, there's a readme. If you click on the right end, triple dot vertically, click and copy path and bring the path here. So that is, if I copy that here, then that is this. So you need to copy this, that's exact same as this, quote. then you can read this. You can read the line, simply read, then it reads that from here all the way here. And the second print statement, if you do all dot split lines, then each line will be in one element in a list. So it says this dictionary includes all the way here. That is one element. Second element is one blank after that. So that is blank here. Third element, starting with a star, few space, back quote, star, few space, back quote, element, California, all the way. So that is that. The reading files, impossible here in the Google Colab. Google Colab, the file space is either you can bring file here by upload this, but don't think about that. There's only trick. That works only for this Colab. If I ask you to do, for example, in exam or any other Python language, Python codings, if it is not particularly about Google Colab, don't follow to work on this Google file space. You should describe file expression to your particular platform, either Windows or Mac OS. This gives you a simple idea how this open works, how read works, how this function works, okay? So don't do it. So what you need to do is, you need to work on, for example, in Python, okay? So I want to make one more file. Okay, this file I can say anything that I can copy. Okay, I want to copy this here. I want to make maybe explicit line, and this maybe space. So 4 lines of data. I want to save this. So Command S for Mac or Control S for Windows. Find out where you want to save it. So I want to save it. Mercy 505 in class Spring 24. I want to make this sample.dat data files, which is not Python file, so you need to change it to all star.star. Then it doesn't treat it as a Python files, only data files. Save. So for example, here 505 in class, then sample.dat, that is the file that we looked at, right? Predicate A, predicate is in the form of that is what we have here, right? So that is a file. Okay, I want to make a path of this. So get info. So that is a location. So copy the path name. And next one here, I want to see f equals, let's say file path. File path is nothing but, I want to paste it. F S24 slash, remember that if it's a Mac, then start with slash users slash jun all the way to that folder, and then there is a called the sample.dat. I want to open it. So many ways that you could do. What is it? Oh, we didn't have iteration at all yet. Oh, we did that already, right? Oh yeah. Okay, here. Yeah, we can do this. So file open, then we open it. We can start with this, read. Okay, open this file and then read. All right, so we say read file equals open, that is a built-in function. That function read the path expression, and I want to read it, so it'll be this mode. I want to read it. Whatever the file, whatever the object pointed by this file, the expression, path expression. So I want to open it. And then I want to read it, right? So as it says, I want to read and print all. So this one's should be here. This open the file needs to be read. So if I execute that, file not found. Sample DAT. No such file. Why it is not? I've never had this kind of error. No such files. It's not written by me, but I copied it. Sample DAT. Oh, this is not sample. My typo. S maple. S maple. My fault. S maple. Typo. So S maple. S maple. So that is read, right? To this, I want to practice more. For example, I want to read for each in F path, print each. I want to make that. So if I do that, then this come from here, right? This print all. And when I do for each in app path, then it's slash somewhere, I think slash. This app path itself is this itself is written here, right? So to avoid that, what you need to do is you need to do read, not this, but read f. Okay, let's do this rather than this. This is open already. So if you want to do that, then up to this is printed, right? And the next one for loop, this is open. Read file is open the file. But when without this, if I comment it, not comment, I need to make a pound sign here. If I do this, then it gives me this. Open and my for loop. For each in that open file, I want to print each. Then first each is this, first line, and second line, and third line, right? But end of this, that is next line, that's hidden, but next line carriage return is hidden in these files. Therefore, after this line, one more line, and then followed by this. If you compare this, then this guy, if we print all, then print as it was here. But in the language, Python language, I made here print. Print means at the end of that line, then I want to make new carriage returns. So if we want to make this like the other case, then you need to make this. Therefore, there's no lines, right? If you do not make any extra lines, each line of these files, then it returns like this. But when you make this print without this, then it'll give us one more extra lines, like here. Okay, but anyway, that is one thing extra. But when I do this, why it didn't give me that? It gives me only one time of print statements. This only, but not the other. Why that happens? That's because this file is open, and I said that this is a file pointer. This file pointer pointing to the top, the beginning of that files. As I read, it's scanning. That pointer scans the files. When everything is read, then that file pointer is placed at the end of the files. If you have an experience of playing cassette tape for your music listening, it's not available now, right? Then there's a real tape. You scan it. You scan all the way to the end of that real tape. If you want to re-listen that file from the real tape, then what you need to do? You need to rewind it, right? So that the reader head should point to the beginning of that file. Only in the case you can replay from the beginning. Exact same thing here, because this is file pointer. So what you need to do is that file pointer, readf dot, there is some functions. Okay, that function is called seek. So I want to seek to the beginning of the files. This is a pointer, the position. I want to make it to the beginning of that positions. So here to here, that is the first statement, print all. From here there, that is it. I read this two different ways. This is read the function. Let's say it. Number one. Number two, using for loop. In order to do that, this is rewinding. Okay. So if you want to rewind this, let's say number 10, it's not rewind all the way to the beginning, but somewhere in the middle, right? 10 positions. See what happens. This is the first to read and print. This is the second read. A is somewhere here. I want to make it more clearly. Say 15. It makes us confused. So this is the first print statements, print all. Second one is somewhere in predicate, somewhere here, decate. If you count this from here, then there is 15 points, right? So the point here is, if you want to read it within colab, this file expression is the path within this colab. So code itself is not going to work in general, right? But if you do it here, like Paizo or any other editor, then the file system is not specifically designated, but on your system, local systems, so that it should be expressed in this Mac expression, or I already explained on the slide, the Windows expression. So either way will work. Okay. So at the end of this, then you can save this to. Let's change it there. Where is it? Somewhere here. Mercy. 505. In class. Here. I can say exercise. And this file is saved in this Python format, Python extension .py. Therefore, we have here smaple.dat, and this is read file underscore exercise.py. So 2 files. Close this. So this is the end of today's lecture. Any